morning, everyone. Our world is frail, and environment is one of the three systems that we need to keep at balance. It is not at this point of time. We expect the world temperatures are going to rise anywhere between 2.4 to 2.8 degrees in the next 70 years or so. The situation in India is even more delicately poised. Uh, 35% of India's area is going to be under heat stress. And that is a significant departure from what the global averages are going to be, 3%. While the environment system is interconnected, the fact that India is at such a delicate position should spring us into action. And by no means I mean to say that we haven't acted, but the pace needs to be significantly upped at this point of time. Decarbonization is what companies are gunning for. And this is not just to be neutral at this point of time, but to be regenerative in nature, where you are able to reduce the impact, not just contain it. What can drive this? Amongst many other things, there is one element that has seen tremendous growth at breakneck speed in the last few years, and that is digital and technology. Digital has been a game changer across industries, and it is now the time to use its power to protect what we care the most about, our environment, by driving efficiencies and promoting decarbonization where it is needed the most. Our session focuses today on the confluence of these two extremely powerful elements, digital and technology and decarbonization. The session titled Leveraging Digital and New Technologies for Energy Efficiency and Decarbonization. We will see four of our presenters talking about how new age digital and technology is going to solve for efficiency and decarbonization. To start the session, I would first call on Gaurav Vyas, lead strategy from Reliance Industries, to come up and share his presentation. Gaurav.
Good morning, everyone. My name is Gaurav Vyas. I'm lead strategy for digitization initiatives from Director's Office for O2C Business. I will quickly go into the presentation. My topic is on leveraging causal AI and knowledge graph to transform operations with enhanced productivity, high reliability, and safety. This is a disclaimer. Uh, this is just for knowledge sharing purpose. All opinion are of speaker only, and there is nothing which can be attributed to Reliance. Secondly, this is strictly for knowledge sharing purposes and does not provide any recommendation on the behalf of Reliance. For any technology to be successful, or for any transformation to be successful, we have people first, then technology, then process, then technology. So for every technology we consider, it's very important to put governance structure and process in place and enablers in place first. So we need to understand that who are our end users and what benefit it will bring. What is the problem and what should be solved. Understand the process and triggers of it, and then we do the value hunting instead of just following a technology and implementing blindly. So before we embark on this technology, we understood that what benefit it will provide, will it benefit my end user, and whether it will reduce the burden on my end user rather than creating an additional platform. So here is a technology which is a groundbreaking technology which combines ChatGPT and causal AI. And with this technology, more than that is required a strong vision which integrates, inspire teams, galvanize leadership, and drive priorities. Here is our imaginary character called Astha. Though the technology can be leveraged into any domain, it can be scaled into any industry, and it can function collaboratively with various functions. But we have taken Astha as an example. She is a chemical engineer and works in a refinery technology services. And typically she has to struggle with too many platforms and too many activities to do, like she has to reply to emails, meetings, she has to provide reports like you must all be doing, creating this data, that data, Solomon data, MIS, and all kinds of documents you have to prepare. Then one has to do root cause analysis for the problems occurring in the unit and the incident reports, etc. And maybe at times leadership presentation and informing to the management and value engineering. So all one has to do in the 8 hours one works, and he or she has to deal with disparate set of data. And there are various platforms like simulation, some calculation platforms, some heat exchanger design, uh, then data books, process design books, and all these documents are disparate in nature. Some are in Word files, some are in Excel, some are PDF, some are pictures, some PFD and PNIDs, they are in pictorial form, and at times the data sets do not talk with each other. They are in not in consonants, and they are stored in different forms, and knowledge is scattered everywhere, and one has to gather, and it takes lot of time. So we found a solution to it. We so what all is needed? There are too many tools which one has to find first, that which tool to be used for what activity. Second, uh, there are too many tools one has to deal with. So we found a panache, which is Cure for All, an intelligent platform which can contextualize information, which can generate reports, which can do root cause analysis, which can combine knowledge and stored in different forms and generate actionable insights. So here is it. This is a platform called Knowledge Graph. It combines ChatGPT and causal AI. AI is uh, advanced analytics, and ChatGPT is something where you can ask a query and it can populate uh, based on that. So this groundbreaking technology is very important in that way that, for example, if you take operation engineer, if he has to take a changeover of fan, he has to look into various set of information, like what is the present unit conditions, what is happening at the unit at this point of time, operating manuals, some past incident, or but with this, he can just simply ask a query that I want to change this XYZ equipment, take change over this XYZ equipment. What are the things which I have to take care? And this uh, knowledge graph will directly take data from process design guidelines, process design book, operating manuals, and it will also take data from the real-time plant data historian and refer incident reports as well. To delve further more into the details, I will call my colleague Ashwini Kapil to talk about this and take this further. Thank you.
Hello, good morning, everyone. Uh, I would like to bring you back to the character Rastha. Uh, so, why is there a problem? There is a problem because she has got predefined reports, which are very prescriptive, and she gets it done through IT or a tool expert. Every time she finds some new problem, she has to go and analyze further because the reports are not enough to provide the information or the insight that she's looking for. Secondly, these reports are something that needs to be interpreted. It doesn't have a to-do action. Or at all, if there are two reports linked together, there is no causality between them available through such a tool. So causality is missing. Thirdly, there are so many experts available in oil and gas industry, but she doesn't have access to all of them in the way she wants the insights or the to-do to be recommended. There is so much of knowledge sitting in these documents that it is difficult for her to go and navigate through the document and analyze and find out what to do next. So the technology that Gaurav has been talking about is something that will be able to create a knowledge model, almost like a base for a platform that will not just have contextualization of information, but also of operational data and put together a recommendation for a character like her. eventually, because she doesn't have the time to go and process all of it this herself, there will be a query platform required on top of it which she can query. You must be thinking, oh, what is so different from ChatGPT? No, this is an internal GPT which can compute as well for you. And on all dimensions of oil and gas coming from any domain, also having interlinked causality between them. Going further, just to elaborate more, so the technology basically that is required here should be agnostic to all kinds of information, whether it is a PDF document, it's a manual, it's an image, it's a PNID diagram, or it's just the Excel data that we've been used to. Apart from that, it should be able to form relationship between all this information, not just from numerical purposes, but also from a first principle model basis or a cause and effect basis as well. Thirdly, it should be able to use the existing systems, the existing plugins, engines, so that they don't go for waste, and those are fed for intelligent insight. And in the end, it should be able to foresee future and recommend you things that are critical for your operations. In the end, it should have a plugin for people to plug their knowledge and also run what-if scenarios so that they can see the various scenarios available in future. Yes, as Gaurav spoke about, the basis of this is knowledge graph. And here are some of the examples that you see. The technology has gone to such a level that now things like manual reports on maintenance, process diagrams, process description, design documents, maintenance manual, damage mechanisms, chemical kinetic formula, reactions, and even your Excel data gets converted to knowledge graph. But the next point will be, how will all this be integrated? So again, the knowledge graph has got capability to integrate the graphs coming from variety of information into one exhaustive model, which is not just linear, but it is infinite dimension. It is almost like a network-like arrangement sitting in the database, almost like a database next to your ERPs. But that will not be enough. Why? Because you are going to access streaming data, so you would need an architecture for both streaming and static information along with this knowledge graph as a database. Apart from that, you should also have something that people call in a non-oil and gas organization as a big data lake, but in this case, an asset information model. If you are able to plug all this together and then have a layer of a causal AI platform or the respective analytics or monitoring or insight engines on top of it, you will be able to generate a lot of insights or kinds of reports or kind of responses that you want from the user. Because it's a knowledge model, because it works on its own and is ever evolving, it reduces the intervention of IT to a significant level. And a query layer on top of that. And of course, you need to do a lot of annotation, you need to do a lot of learning of this for the user to go and just check. So gasifier number 2, what's the operating performance? How is it doing? When is it going to fail? Are the kind of questions you can get the responses to on the fly. So you must be thinking all this is very imaginary. Thanks for that. But we have already picked up a problem which was related to oxychlorination, where an oxy reactor was getting problems because of a sparger damage. And not a clear root cause was found, because every time there was a new root cause with which this oxy reactor sparger was getting damaged. We were even not sure what are the various causes and how they are linked. So the problem was very apt for applying something like a knowledge model and causality on top of it. What we did, again, as I told you, the process we followed, we referred all kinds of descriptive documents, images, to create graphs which had non-standard information to convert into a graph so that it becomes usable, and coupled it along with relational data, which is the operating performance, IOW violations, thresholds, your historian data, etc., to be able to create a model which is on the extreme right-hand side, as you see, is one of the real graph that how it looks like. Earlier it was very exhaustive, but with annotation and collaboration with the experts, it eventually became a very a thin causal model that was able to ingest information and create root cause on the fly. The red lines that you see here are inversely proportional factors to a leading indicator and eventually a sparker damage. And the green lines are direct proportionality depicted by one of the factors on the oxyreactor process chain or the oxychlorination process chain down to the copper loss, which was a proxy for a sparker damage, because you can't open sparker on a daily basis and check whether it has got damaged or not. So eventually it was able to create a causal model that gives you the causal strength of each of the factor in the process to the next indicator. It is so powerful that when you do advanced analytics, you can only have a multivariate analysis where you can worry about what factors might have caused this particular problem. But here it can go down backward in the process and bring up the effects of any length of factors that exist in the process behind to tell you what it had an eventual impact on the final metric. The first thing is, it is a democratized solution. You all can make it yourself once you get trained. Everyone creates their own knowledge graph. The knowledge graph integrates finally together with collaboration. Here we do modeling first and not data sanitization, or we do statistics or those kind of equations. And thirdly, it is reusable.
Ashwini, last 10 seconds.
Right. We were able to create what if scenarios with this. And all I want to say is the more functions you can add with this, the more impact you can create. Whether you want to add finance function, HR function, or any function that has got causality related to your existing operations. Thank you.
Thank you so much, Gaurav and Ashwini. It was really a really nice presentation, I would say. And this is a really need of the hour of this industry, where we can have a trust on this integrated asset hierarchy model, right? And then all this knowledge graph that you have shared. Definitely we'll have a Q&A session at the end of our this particular session, right? So we'll have a lot of questions on this. This is really a a presentation or like a solution that you have developed, which is need of the hour for oil and gas industry as of now. Thank you so much.
Can I now request Ilius Mondal, Senior Geophysicist from ONGC, to come and present on his topic, please?
Good morning, everyone. Thanks for coming. I'm delighted to share my work on ML-driven workflow for large-scale geological storage characterization, paving the way for sustainable energy future. My name is Ilius Mondal. I am working as a senior petrophysicist in ONGC. The outline of the presentation will follow: introduction, motivation, the energy dilemma, and data and scale, since it is multi-scale modeling, results, way forward, and I will conclude. Our work is a kind of symphony of growth, collaboration, and transition, which is a theme for this conference as well. How? Because optimizing a large-scale geological storage is a need for the hour for the exponential growth related to the understanding of subsurface, and it's a convergence of traditional geological practices with some advanced machine learning algorithms for a multi-domain collaboration in storage characterization, and finally the outputs will going to give us the guidance for the seamless transition towards a future-ready paradigm. Everyone whosoever is sitting in this hall, they are well known about this fact that the concentration of CO2 is constantly increasing if we consider it for the last 200 years, and along with that, the global temperature is also increasing, and everyone is committed to limit it below 1.5 degrees Celsius in terms of the increase of that temperature. India is among the top 3 emitters for these CO2 emissions after China and USA. And in India, most of these emissions are related to electricity, agriculture, and manufacturing. And if we bifurcate that in terms of the source, then coal, oil, and gas. These are three major contributors. And as I have already mentioned, that India is also committed for achieving its green goals. We have our honorable Prime Minister also. Uh, he has declared that India will be reaching the capacity of 500 gigawatts of renewable energy by 2030, and India will be producing its energy need at least by 50% by 2030, and significant amount of these CO2 transmissions will be restricted before 2030 itself. And most importantly, even in the inaugural ceremony also, our Prime Minister has mentioned that India is going to achieve its net zero target by 2070. Ha. In this particular aspect, carbon capture is something which will be going to give us the system flexibility unless we get some dependable source for energy. And this will be helping us in avoiding the current lock-in situation and going for achieving the net zero. And studies has been carried out in different sectors. They have suggested that we have in the entire uh, earth, we have our deep saline aquifers, depleted gas fields, and other basalts, where we can store our carbon dioxide, even though we emit with the rate which we are actually right now for the next 2 centuries, so which is quite significant in number. And why hydrogen storage is important? Because in spite of having a very high energy density, hydrogen is having a very poor energy density in terms of its volume. So we need to store it for a optimized, or rather kind of economical scenario. And for that case, we need to maintain a very high pressure, or we have limitation for the temperature as well. In that case, underground storage can be something which will going to give us a paradigm growth in this particular aspect, because most importantly, undergrounds are devoid of oxygens, and if that will be most important for the storage part. So, in this particular time in the energy industry, specifically for the geoscientists who are there, they are having this dilemma whether we should continue with the fossil fuels, for which is actually our core business, because we have so many assets, so many things, or we should reduce the use of fossil fuels for imparting the global warming, and we should have a push with the alternate energy. So parallelly, these two things can be done with the knowledge which we have for the legacy of expertise in oil and gas industry. We can carry out our conventional things, and along with that, we can incorporate that approach, and we can actually integrate the machine learning or advanced technologies to go to the greener future as well. And because in oil and gas industry we have financial strength, focused strategy, advanced infrastructure, and I already mentioned deep expertise, and we are having that legacy for so many decades. So, in line with this thought, this multi-scale modeling is something which is kind of very important aspect in this particular time, where we have integrated from the core scale to log, then integrated to seismic, and then property upscale for a better geological understanding for the particular reservoir, and as well as to see how efficient it is for the storage part. The workflow actually integrates with porosity and permeability, because these two things are quite important, because porosity is just something which is going to give us the storage capacity, and permeability is something which is associated with the dynamic nature of the fluid, be it CO2 while time of injection, and be it for the case of hydrogen, be it in the time of injection, and as the in the time of retrieval also, or the production also. And during different steps, we have incorporated the machine learning algorithms like categorical boosting, ASM classification, probabilistic neural network for upscaling and trying to give a good idea about the seal integrity of the subsurface. The study area is a offshore carbonate field, and where we have a very good succession or the very thick succession of limestone formation. And in that case, we have upscaled the porosity permeability relationship from the existing code data sets and upscale it in the logarithmic scales, allowing the idea of the species utilizing the machine learning algorithms like soil progress maps or SOM. And then we have integrated these outputs in pre-stack inversion attributes, and we have trained our model utilizing the PNN, and we get the porosities and permeabilities with a very good percentage of accuracy. And when we upscale this in different slices of that reservoir, specifically these two figures are along two reservoirs, and as you can see that optimizing the good amount of porosities and permeabilities, we can actually optimize the selection for the storage site, or which places are actually good enough if we want to store our carbon dioxide or rather hydrogen in near future. And this is also helpful for the traditional field development strategies in our oil and gas. And this is something which is quite important because this field is actually very old. Most of the wells were drilled below 1990. So we didn't have a good amount of advanced log data sets. So for that case, we have tried to model the advanced log data sets like nuclear magnetic resonance, because in nuclear magnetic resonance or NMR, we have we can see, or we can visualize the distribution of the pores, and this is quite important for the case of understanding the reservoir, and as well as for the understanding of the seal integrity as well, because smaller pores will be normally, I mean, that is going to give us a good seal integrity. So for that case, we have utilized the categorical boosting, and we have modeled the nuclear magnetic resonance for the older wells. And just for a comparison, this is something which is for a particular well where we have the recorded NMR data. And second track, you can see that we have modeled the NMR data, and that is a quite good match in these two outputs. So we have propagated this model in the entire feed, and we can optimize the integrity, or rather the seal integrity of the reservoirs. And from this nuclear magnetic resonance data set, we can also go for the capillary pressure modeling, and that capillary pressure modeling can give us a good advantage in the time of the reservoir simulation part as well. So this is something which actually is going to give us a good advantage, even though we have very old data set or very old fields which are devoid of any sort of advanced logs. Um, these are the way forwards. Like we need to we need to understand the rock fluid interactions, which is a topic of study in addition to our work, and we need to model or simulate how CO2 or hydrogen is going to behave when we actually inject it. And for most, since oil and gas industry, we have to see the cost benefit analysis as well in terms of the carbon credits or other things. So if I conclude, I will be saying that the sustainable energy future is hinges on the large-scale geological storage, specifically for CO2 storage and hydrogen. Because for hydrogen, it is quite important, right? Because uh, this is something which can be stored in terms of energy. Otherwise, if we want to store the energy, the number of batteries or the number of the amount of investment will be quite high. So hydrogen in that particular aspect can be something which can be in near future as well, which can be beneficial for us. And utilizing the machine learning algorithms, we can actually optimize the reservoir reservoir uncertainties or reservoir characteristics for these for optimize site selection for the injection or production. And our work is a fully integrated approach, leveraging the oil and gas expertise which we have right now, and this will be guiding us for a future-ready avenue in Indian energy landscape as well. Sorry. I will just conclude my presentation with just one line that the future belongs to those who prepare for it today. Thank you so much for your patience. Thanks.
Thank you, Ilius Mondal. I see you have already saved 2 minutes here. Thanks for that. And it's a perfect example of domain plus data science skill that you have shown here, right? But overall, this presentation is going to help and to share the knowledge that you have done here, and it's going to help us to implement this the underground storage for net zero gain that we are targeting. Thank you so much, Ilias. Over to you.
The only comment that I'll also make is while there are multiple the technologies which are trying to reduce carbon emissions, there will be industries which will not be able to do without carbon capture. And figuring out the ways to utilize it in the most efficient manner is probably one of the most technical challenges that we need to solve for. So great progress on that and congratulations. Can I now request Phanishwar from Hindustan Petroleum Corporation Limited to come up and talk about his presentation?
Yeah, good morning to everybody. Myself, Phanishwar Kumar. I am working as Manager Technical Services at Hindustan Petroleum Corporation Limited, Mumbai Refinery. Today, I will be taking you through some of the applications that we have done in the gasoline block using simulation and machine learning for the maximization of gasoline production. So the agenda is simple. I will walk you through the basic configuration of our gasoline block, then the application of process simulation in these units, subsequently application of machine learning, and then I will walk you through a project that we are working on that we need to bring about synergy between simulation and machine learning and why it is required. And finally, I will be concluding the presentation. So this is the basic configuration of our refinery. We have two CDUs. One runs on a high sulfur crude, another on low sulfur crude. And the SRN produced from these CDU units is routed to our naphtha splitting unit. So this is the basic configuration of our gasoline block. The SRN is sent to the naphtha splitting unit. From the top, you get light naphtha, and from bottom, you get heavy naphtha. Heavy naphtha is the prime feed for the CCR unit. And whatever additional amount of naphtha you require to meet the CCR feed requirement, that will be used from, taken from FBS, that is heavy naphtha from CDUs. And from our crack naphtha stream, we have a prime G unit licensed by Axens. This is our typical gasoline pool composition. Reformate is generated from CCR, isomerate from ISOM. Light gasoline and heavy gasoline are from prime G unit. Pentane is from our hexane unit. So process simulation, we all know what is process simulation. So what benefit it gives us? It gives us an understanding of the process. Basic physics and chemistry of the process can be understood using process simulation. It can help us in predictive modeling. It can help us in design and planning, and also for the validation of historical data. These are the tools that we are using at Mumbai Refinery. Everyone knows about Aspen HYSYS and Aspen Plus. Conval is a software that we use for simulating the behavior of instruments, control valves and ROs, etc. in different operating scenarios. And DWSIM is an open source simulation software that also we are using. So coming to the gasoline block, the control of the feed quality parameters in gasoline block is quite critical. So as you can see in ISOM, there are two critical feed quality parameters, paraffin isomerization number and X factor. So more is the paraffin isomerization number, better is your feed. More is the X factor, worse is your feed. X factor extensively depends upon the C7 plus content in the naphtha cut. So more you have C7 plus content in your light naphtha cut, worse is your ISOM feed. So we need to control C7 plus content in the ISOM feed. Similarly for CCR, N plus 2A is a parameter that governs the feed quality. Higher is the N plus 2A, better it is to convert into reformate and get octane number. IBP, FBP is another parameter. And then again, the benzene precursor is one critical parameter. So we need to control benzene precursors in our CCR feed so that our MS production is not hit on benzene content, because we have a regulation of less than 1 volume percent benzene content in MS. Coming to the benefits that we have been able to derive from simulation, we have been able to reduce our reformate benzene content, and also because of that, the gasoline block Ron barrel maximization has been achieved. Generation of gasoline block delta vectors we have done. Maximization of asset utilization in our gasoline block. We have been able to operate most of our MS block units at more than revamp capacity. And then we have been able to minimize the energy consumption. Although we are operating at more than design capacity, our energy consumption is less than design value. So I will walk you through those. Coming to the reformate benzene and gasoline block octane barrel maximization. So typically your NSU overhead temperature is increased to reduce CCR feed benzene precursors. But the disadvantage of that is when you increase it, the C7 content in your isom feed will also increase. So it will improve the performance of CCR, but it will reduce the performance of your isom unit. But one anomaly that we saw is that whenever we were increasing our NSU overhead temperature, our benzene was not coming down, which was counterintuitive. So we carried out a simulation. What we came to know is that when we are using NSU overhead temperature, our HN yield is also dropping. And because of that, we are compensating the CCR feed with FBS. Now, FBS has certain benzene precursors. You can see the C6 line, right? Around 3.19%. So since we were increasing NSU overhead temperature to reduce benzene precursor, we are also mixing more FBS also in CCR feed. And because of that, the benzene content was not coming down in reformate. So after simulation, we came to know that there's an optimum range of temperature of NSU operation, that is 82 to 84. Beyond 84 degrees centigrade, it is counterproductive to increase the NSU overhead temperature. Furthermore, the NSU top temperature was negatively impacting the isom feed quality. You can see the X factor was going up along with the light naphtha C7 plus content. So next, coming to the generation of gasoline block delta vectors. So what is delta vector basically? For example, let's say we have a parameter called RON. So there are several independent variables in CCR unit. So delta vector will tell you how much the RON is going to change with the feed rate, with the weight, or with the H2 by SC ratio, etc. So this is very critical parameter to generate for the planning purposes, because our planner has to know that if I change the crude quality that is coming to the refinery, and if I change the feed quality coming to the CCR or isom units, how much it is going to impact my yields and octane number. As you can see in these graphs, we were able to generate reformate RON and reformate yield variation along with N+2A, as well as the reactor severity. And this helped us a lot in planning the optimum operating conditions for the CCR unit. This is the summary of the isom and CCR delta vectors. You can see that for each independent parameter, we have a delta vector for RON and as well as yield. So this is a very handy tool for the operator as well, because he will know how much to change the parameters to achieve their target RON and yields basically in these units. Coming to the maximization of asset utilization, there are two units in which we achieved asset utilization maximization. One was in prime G unit. In prime G unit, the design capacity of unit is 105 meter cube per hour. Using Conval and Aspen HYSYS simulation, we were able to debottleneck these units, and we were able to achieve 135 meter cube against 105 meter cube. That is 30% additional capacity above the revamp capacity basically. And in our isom unit, we were getting bottlenecked at NHT capacity. So we saw that our hydrogen generation unit PDS is having some residual capacity. So we carried out simulation, and we found that if we utilize our PDS naphtha treating unit to generate hydrotreated naphtha and route it to isom, we can achieve 8 meter cube extra per hour, 8 meter cube per hour extra MS production. Now coming to the energy saving part, DIP column in isom unit is a major steam guzzler. It requires around 14 to 15 TPH steam consumption. The design IC5 recovery is 90%. We wanted to see whether this much recovery is required for our MS production or not. Based on simulation, we came to know that if I operate my tower at 70% IC5 recovery, I'm getting a RON of 88.1, and at 90% I'm getting 88.2. So hardly 0.2 units difference is coming in the RON. But at the same time, the net gain, if you can see in the red color in the bottom, is in negative. I'm actually losing money because of the higher utility consumption. So we implemented this idea, and we got a OPEX reduction of around 70 lakhs per annum, as well as the energy reduction of 1900 SRFT, which is equivalent to around 5,000 metric tons of CO2 per annum. Now I will move to the application of machine learning part. So these are the different use cases for machine learning, but I will be focusing my presentation on process optimization via predictive analytics. So what is predictive analytics? Keeping it simple, predictive analytics is predicting the future outcome of your plant based on the past data. You feed the machine learning model your past DCS data as well as lab data, and you try to predict the future outcome of the plant. It involves 5 steps: data collection, data preprocessing, model building, model training, and model validation. This is the first model that we implemented, that is SRN RVP prediction. So the naphtha that is coming to our MS block, the RVP control is very critical in it. So what we tried to do is we try to understand what is the impact of each variable on the SRN prediction. And these graphs are just the part of our preliminary data analysis. Then the next stage was to understand the dependency of each variable on each other. So the heat map that you are seeing on the left top corner explains how much one data set is dependent upon another data set. One parameter is dependent on another parameter. The right side bottom corner, the graph is showing that what is the relative importance of each parameter from the perspective of RVP control. So as you can see, a stabilizer, a reboiler outlet temperature is the most critical, followed by stabilizer overhead pressure, LPG flow, and crude API, etc. This was the training result, and we got quite a good mean absolute error of 0.13, which is pretty good. And then we deployed this model online for the operators to see. And this is the actual screenshot of our actual model deployed on the server. The best part of these models is that it is completely in-house. From back end to the front end, development has been done in-house by us. Coming to the isometric RON prediction, similar to the RV prediction model, again, we try to understand the dependency of each variable on each other. Then the model was developed. It has pretty good mean square absolute error of 0.25. For a octane number of around 88 unit range, 0.25 mean error is quite good. So we were able to deploy that also, and the benefit that we were able to extract from it is that we were able to reduce our steam consumption by 3 metric ton, which is equivalent to around 1600 SRFT per annum, and which is equivalent to 400 metric ton of CO2 emission per annum. We were able to operate our ISOM unit at 105% capacity. Yield improvement of 1 to 1.5% was achieved, and we were able to maximize our octane barrels also. So December 2023 was the month in which we were able to produce our highest ever MS production. Now coming to the part of integrating simulation and machine learning, why it is required. So although there's a hype about machine learning and all that, it's a very good technology. Indeed, it is a very good technology, but it fails miserably for the data points for which it has not been trained for. For example, I have trained my model for a feed rate from 100 to 150, and now my plant starts operating at 90. My model will fail. So what to do in that scenario? So in that scenario, simulation can come in aid of the machine learning models. You can generate a well-tuned simulation model. You can run a well-tuned simulation model to generate the data that you don't have for the machine learning model right now, because your plant has not operated in past in that range. So that is what we did. As an example, as a test case, we took CCR unit and we generated simulation results for the operating scenarios which our plant has never faced. So that data was fed into the machine learning model, and we were able to extract the delta vectors for each and every parameter when it comes to the octane number as well as yields. So this is very useful for planning purpose as well as operating condition maintenance. This is the model prediction. So coming to the conclusion part, these are the benefits that we were able to derive in last 1 year basically. All these models and the simulation model as well as machine learning models have been developed in last 1 year. And then the benefit was around 3,500 SRFT per annum reduction in energy. CO2 emission reduction around 9,000 metric ton per annum. Our HN yield maximization was done while minimizing our reformat benzene. ISOM octane barrel maximization. We were able to generate our ISOM and CCR unit delta vectors for planning purposes. We were able to debottleneck our prime G unit by maximizing the feed rate by around 30% above the revamp capacity. We carried out the feasibility study of routing PDS naphtha to our ISOM unit to increase the ISOM product maximization. And then the real-time prediction of SRN, RVP, ISOM rate, and reformate RON, as well as yield using machine learning was done in last year. So the way forward for us as of now is that we are trying to develop more models like CCR, which is having integration of simulation as well as machine learning, which will be more robust and will help the operator to predict the plant behavior and make them more smarter to control the plant behavior in future. Thank you. Thank you very much.
Thanks, Phanishwar. Excellent stuff. I see you have presented and you have shared your knowledge of overall gasoline process optimization using different methodology, right? Starting from conventional approach to machine learning and then the integrated approach. And I am sure this integrated approach is going to work because in our oil and gas industry, we have lack of data, right? And that's why we are not we are not able to leverage the power of machine learning. The synthetic data that you are generating from your conventional model and put it in machine learning model, definitely going to help, right? Thank you so much. Excellent step, Phanishwar. Now, Nishant, next to you.
Last presenter for our session, Shamsul. If you can come up and talk about graphene.
Okay, all right. Good day and good morning, everyone. First of all, thank you to our chairperson for your kind introduction. I'm Shamsul from PETRONAS Kuala Lumpur, and the topic that I'm going to share here is about our advanced materials, which is graphene, which is related to the unlocking new opportunity for sustainable future in energy industry. Okay, ladies and gentlemen, PETRONAS is a multinational oil and gas and energy company. We have initiated this kind of moving forward together agenda, 50, 30, and 0, which with the aim of 50% improvement in cash flow from our core business, 30% revenue by 2030 from our non-core business, and 0 net carbon by 2050. And this kind of objective or aspiration is in response to long pandemic 19 and this impact our oil and gas business. And further, with uncertainty in our economy, world economy situation, and as well as new energy transition requirement for our future world energy transition. And to support this kind of agenda, PETRONAS through project delivery and technology have initiated a few or several focus areas, which are specialty chemical, renewable energy, hydrogen, circular economy, and for our graphene project, it's under these advanced materials. And for our graphene technology, it contributes in terms of sustainability from converting our petroleum refinery waste, which is coke, to a valuable product, which is a graphene. And this kind of graphene, we convert it into a valuable product such as for coating, battery and composite application, which it have in terms of circular economy initiative. And in terms of graphene resource, we have quite huge in terms of the raw material, which is coke. The volume is around 450,000 metric ton of petroleum coke produced every year. And using our patented technology of graphene, using molten salt technology, where we call it as electrochemical exfoliation, with 70% less energy consumption, we can produce a high quality of graphene, and it's a modular kind of reactor. And from there, we can produce high quality of graphene that can be applied for different applications that suit with oil and gas and other industry. And graphene in a nutshell is about carbon material, is single layer of atom that arranged in a hexagonal structure. And this type of graphene is a 2D material, which is different as compared to other type of filler, which is a 3D form. And this graphene properties, it has kind of very good feature in terms of the mechanical properties, its electrical conductivity, thermal stability, the permeation, the barrier, and these kind of properties for the commercial value is depend on how success we can formulate this graphene for different type of application. And as you can see here, this is the raw material, our petroleum coke. Basically, our petroleum coke is contained of 80% of carbon, and then some is contained of nitrogen, hydrogen, and also the sulfur. And this kind of petroleum coke is in homogeneous or unorganized carbon layer, and it requires quite a high temperature in terms of to converting into a graphene to have a very good in terms of graphitization. And compared to other raw material for the graphene, like graphite, it has a very good in terms of high organized carbon, which easy to process compared to this petroleum coke. And using our patented technology, using this kind of reactor, this molten salt technology, we're able to produce a quite consistent in terms of graphene quality. This graphene quality is based on, we check on the Raman spectrum. We measure in terms of the ratio of a 2D peak with a G peak. As we can see here, in terms of the value of this ratio is close to 1, where it's a 0.85. And it's consistent, starting where we produce it start from 2018 until 2022. And it's proven that even the source of the graphene petroleum coke that we got it every year is different, but we managed to produce very high quality of graphene. And not only to produce this graphene using this reactor, we also do some modification, or we call it as a post-treatment of this graphene, to ensure that the graphene produced can be applied in different applications, where we do kind of a ball milling process, washing, and as well as improve the dispersion of the graphene to get very good in terms of the lateral size, surface area, and as well as the bulk density. And as we can see here, from this post-treatment also, we managed to increase in terms of the carbon number, and as well reduce the impurity. And battery is one of our main application for this graphene, where for this battery application, it can improve in terms of better thermal performance, about 1.4 times, and 50% improve in terms of the faster charging, and also 50% improvement in terms of longer life cycle for lithium ion. And in terms of the conductivity enhancement, we have tried for the NMC and LFP battery, and we can improve about more than 40 to 60% in terms of the lower impedance or conductivity. And this graphene has a very good feature in terms of application for the EV car, robotic, and energy storage. And this is some our work in the lab, where we produce a prototype, a post-cell design of a lithium-ion battery. And we compare in terms of the conductivity. We compare the system, the electrode that currently using CNT, and we compare the one that using a graphene where we call it as a pro-charge. And we can see here at different cell from 1, 2, 3, and 4, it consistently show that the impedance value is lower, which show that demonstrate that graphene conductivity improve more than 40%. And there is another study where we study in terms of the charging rate, where the first chart here on the left side, where we study in terms of the charging rate from higher charging rate at 60 minutes to 6 minutes, we can see that for the system with the graphene, the pro-charge one, it can give higher in terms of the discharge capacity even when we charge at very high rate. And the chart on the right side here, we compare in terms of the number of cycle charging and discharge up to 500 cycle, and we can see it proven that the red line here for the pro-charge with the graphene, the discharge capacity of the battery is improved, is consistent high at 65%, is higher compared to the conventional system without graphene. And this is another application, we call it as a Porsche bus. This is our trade name, where we incorporate our graphene master batch in protective coating. And the function of graphene in this type of paint, it will further improve in terms of barrier properties, because the graphene will form a tortuous pathway, and from there it will slow down in terms of the diffusion of corrosion agent like oxygen and water to penetrate from the coating to the metal substrate. And this is because of graphene has a very good in terms of high surface area, high aspect ratio, and hydrophobic. It can form a very good layer and protect further the coating system and improve the corrosion resistance. And the target application for this graphene paint is we target on application for oil and gas, general industry, the power structure, and also for the marine application. And this is one of the study where we study in terms of the impedance resistance of the graphene coating, where we study at a different loading, start from 0.05 and 0.2%. As you can see here at loading 0.05, it shows very good in terms of the impedance. It shows higher in terms of resistance to the electrolyte, where it proves that this graphene gives a very good in terms of the water barrier properties. And other than that, we also study in terms of the long-term performance under the corrosion resistance, where we expose our coated panel. We can see here the yellow color is for the conventional system without graphene, and then the green color one is with graphene. As you can see here, where we apply the stripe, the X-cut, and then we expose for 3,000 hours under the south spray, and then we can see the performance of graphene. It's very less in terms of the blistering and also rust under the coating surface. And in terms of the rust strip under the coated surface is much lower. It's about 2 times lower as compared to the system without graphene. And the study also has been carried out where we compare the test that has been carried out in our lab, and also that we apply in actual field, where we expose our graphene paint in splash and spray zone. Basically, there is a number of tests where we study in terms of the water barrier using the EIS, and then we study in terms of the bonding between the paint and the seal substrate, and the long-term test including this south spray for 3,000 hours, and also the cyclic UV for 4,200 hours. So from this result, we can see the consistency in terms of the performance between the lab and also the field trial, where you can see here for the graphene system, it shows consistent in terms of the performance improvement as compared to the system without graphene. And this is our deployment. We deploy this technology in our offshore project, where we paint it for boat landing area for splash and spray zone, and as well we applied it for our petrochemical plant structure. And The study that we carry out during the pilot trial is we check in terms of the addition, the contact between the paint and the metal substrate, and then it proved that the number that we obtained from this study is quite high, where the requirement for the addition pull-off test is only about 500 psi, but the result that we have is about more than 3 times higher than the criteria. So it proves that the information that we have using our petroleum coke graphene demonstrate very good in terms of the performance for this paint application. And this one is another application where we incorporate our graphene for the composite application, where this composite can be applied for different type of application for automotive, hydrogen tank, for structure, and also for aviation industry. And this type of, we call it as a graphene composite, can be processed through filament winding, resin infusion, and also effusion for the thermoplastic. And in terms of the application, this is an example. We functionalize our graphene with the epoxy using the filament winding process, and then in terms of the performance, it improved in about 90% for pipe burst pressure, and also for the functional graphene for non-woven system. We added for polyester vacuum infusion, and you can see the improvement is around 87% for the flexural modulus and 61% for flexural strength. And for the other application in the thermoplastic polypropylene extrusion, it also can improve for the flexural modulus, and also the flexural strength is about 26 and 55 and 50% respectively. And this is an example of the performance test that we have carried out in our lab, and also for during the pilot, where we make it into a hydrogen cylinder, and then we test in terms of the burst pressure. For the graphene system with the epoxy, we can get almost 800 bar for the system with graphene, and for the normal conventional one without graphene is much lower. It's only about 700 bar. And for the graphene flex polyester, it also can improve in terms of the flexural modulus and the flexural strength as compared to the system without graphene. So as for the summary of this presentation, PETRONAS successfully produced our graphene using our petroleum coke, which we know as this waste product. We can convert it into a very, very valuable product. For this one is a graphene, and we managed to formulate this graphene for different applications, and it worked successfully. And this kind of technology support in terms of PETRONAS overall sustainability agenda by transforming petroleum coke into a high-value product that could be applied in various applications. And the use of graphene in battery, coating, and composite material has facilitated in terms of the shift to clean energy source, while also improving in terms of asset service life and structure integrity. I think that's all from me, and thank you very much.
Thank you to all the 4 presenters. May I request the presenters to come up on stage?
We had a wonderful 4 sessions here, and I see all those 4 sessions were equally important in a new technology and for the new opportunity that we could have, starting from Gaurav and Ashwini, and then we had a session from Ilius, then Phanishwar and Shamsul. All this technology is something where we can learn a lot, and there is a lot of opportunity that we can implement in oil and gas industry. So with that, I would like to thank all the participants and all the audience who has witnessed this session. Thank you so much. Anything, Nishant, you would like to add before we conclude?
Thank you to all the participants for being here, and to all the presenters. Thank you so much.